Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams IFM, IFM, and LTAM that I offer. You simply go to these URLs and you'll get all the information. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students at Illinois State University, please go to smarturl.it/help ISU actuary. Here's the problem for today for exam IFM. A market maker sells 1,000 one-year European gap call options and delta hedges the position with shares. Each gap call option is written on one share of a non-dividend paying stock. The current price of the stock is $100. The stock volatility is 100%. Each gap call option has a strike price of 130. Each gap call option has a payment trigger of 100. The risk-free interest rate is 0%. Under the Black-Scholes framework, determine the initial number of shares in the delta hedge. And here's the solution. So note that the risk-free interest rate is 0, R is 0 therefore, and delta, the dividend yield continuously compounded of the stock, is also 0. The formula for the time zero price of the gap option is S times n of d1 minus 130 times n of d2. It's simplified because those two rates are 0. And 130 can be written as 100 plus 30, so we split it into S of n d1 minus 100 times n of d2 minus 30 times n of d2, which is C minus 30 times n of d2, where d1 and d2 are calculated with k equal to 100 using exercise price of 100, and C denotes the time zero price of the plain vanilla call option with exercise price of 100, and we basically refer to the standard Black-Scholes formula in this approach. In the Black-Scholes framework, delta of a derivative security of a stock is the partial derivative of the derivative security price with respect to the underlying stock price. In this case, delta of the gap option is, because of being able to write that price as the difference of the two, that's the delta of the regular call minus 30 times the partial derivative with respect to S of n of d2, and that's equal to the delta of the call minus 30 times the derivative of n, the cumulative distribution function of standard normal distribution, derivative of it, and then at d2 times the partial derivative of d2 with respect to S, and then that's equal to n of d1 minus 30 times the PDF of the standard normal distribution, which is 1 over square root of 2 pi times e to the minus x squared over 2 at the value x. So in the case of taking the value at d2, this becomes e to the minus d2 squared over 2 divided by square root of 2 pi. And then the derivative of d2 with respect to s is 1 over s sigma square root of t. And of course, just a reminder, while we don't have a formula for the cumulative distribution function of the standard normal distribution, because the integral of the cumulative distribution function, of the probability density function of the standard normal distribution cannot be expressed as a formula. It's a transcendental function. Nevertheless, we know this, so we can just write it like this. We substitute S equal to K equal to 100, T equal to 1, sigma equal to 1, and obtain D1 equals, effectively it just becomes 1/2 sigma squared of T, which is 1/2. Sigma is equal to 1. And d2 is equal to d1 minus sigma squared root of t, so it's 1/2 minus 1, so it's negative 1/2. So that the delta of the gap option is n of 1/2 minus 30 times e to the minus 0.5 squared over 2 divided by square root of 2 pi times 1 over 100 times 1 times 1. And this is all something that we can calculate with, of course, the cumulative distribution function of the standard normal distribution at 1/2. We need to evaluate it either with a calculator giving us that or the table, but on the test you're actually given that type of a calculator that calculates it. But nevertheless, it's just a straightforward calculation. And for 1,000 gap options sold, this means that approximately 586 shares are needed to hedge. And that's answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.